All right, pick a science teacher, any science teacher, or at least any teacher who teaches the physical sciences. Ask them what's one of the most frustrating ideas to try and get into their students' heads, and I'll bet you a bunch of them would come back the difference between mass and weight. Mass and weight, different things. They are not the same. Mass does not tell you how much something weighs. There are two separate ideas. Now, on Earth, part of the problem is that mass and weight are completely and directly proportional. When one goes up, the other goes up. So most people never think to notice a difference between them. However, there is a difference, and that is what I want you to learn here. Mass is a measure of the inertia of an object. That is, mass tells you how hard it is to change the motion's object. Weight is the force of gravity acting on an object. So here's some things to help you remember the difference between these. Weight depends on gravity. If gravity goes up, so does weight. If the force of gravity is reduced, so is weight. Now on Earth, gravity is the same everywhere, so we never ever have to stop and think about this. But for astronauts who travel into space, the force of gravity is, for low Earth orbit, negated by the fact that you're falling with the spacecraft, and so you effectively have no weight in space. Again, as the force due to gravity is reduced, so is weight. Now mass, the measure of the inertia of an object, that never changes. Think about how difficult it is to get a car rolling on the surface of the Earth. If you were to put a car out in space, it would still be difficult to get into motion because of its inertia. That's mass. That never changes. So, for an example, if we take our astronaut Sticky, say hi, Sticky. So there's our astronaut, and we send him into space, and we say his mass is going to be 50 kilograms. His mass, the measure of his inertia, does not change. Now his weight absolutely changes, and let's look at how to find his weight. So let's find, this is Sticky, let's find Sticky's weight on Earth. So we'll make a note that this is on Earth. To find the weight of an object, all you have to do is you take the fact that the weight is equal to mass times acceleration due to gravity. Wow, that's so long to write. Weight is mass times acceleration due to gravity. Now, notice that this is really just a special case of Newton's second law of motion, which is why we talk about it here. Weight is a force. Look at that definition. It's a force. Weight is a force, mass times an acceleration. So this is still force equals mass times acceleration, except now we're saying that the specific force we're looking at is weight, and the acceleration we're looking at is the acceleration due to gravity. So on Earth, Sticky's weight is going to be his mass, 50 kilograms, times the acceleration due to gravity on Earth, which you should remember. Did you say it? I hope you said it. The acceleration due to gravity on Earth is 9.8 meters per second squared. If you said 10, I will go with that. That is just fine. And so we find Sticky's weight to be 490 newtons. Remember, Newton is the SI unit of force. However, we're not used to using the SI unit of force. We're used to a different unit of force called the pound. And in order to convert newtons to pounds, this is kind of an aside. You don't have to know how to do this. It's just kind of nice. To find a weight in pounds is the weight in newtons divided by 4.45. So if I want to find Sticky's weight in pounds on Earth, I would take 490 divided by 4.45, and so he weighs 110 pounds. We call him Sticky for a reason. I'll write in parentheses that this is 110 pounds. All right, that's Sticky's weight on Earth. What if we put him in space? So weight is still equal to mass times acceleration due to gravity. I'm just going to abbreviate acceleration due to gravity that way. So in space, his mass does not change. Remember, mass is the measure of the inertia of an object, as we stated up here, so that's not going to change. So his mass is still 50, but in space, the acceleration due to gravity, there is no gravity. So we're talking 0. 50 times 0 is 0 newtons. So just by changing Sticky's location, we actually changed his weight. How's that for a weight loss plan? He lost 110 pounds in the few minutes it took to get to orbit. So the difference here is the acceleration due to gravity. Weight is a force. Mass is a measure of inertia. And note again that weight is measured in units of newtons. Mass is measured in kilograms. So big difference between those. Now this is just because it's interesting. We can find Sticky's weight on other planets. And this one in particular is of interest because it's a planet that we will probably want to go to one day. Let's find Sticky's weight on Mars. So weight is mass times acceleration due to gravity. We know Sticky's mass because that doesn't change. So it's still 50 kilograms. Now we just need to know the acceleration due to gravity on Mars. There are ways of figuring this up that you're probably not ready for. No offense, it's just a lot of math. But one of the nice things is there are other people who are really good at math who have already done this for us. So we can find that the acceleration due to gravity on Mars is 3.72. Notice how much smaller that is than the acceleration due to gravity on Earth. And so now we're in a position where we can calculate Sticky's weight on Mars. It would be 50 times 3.72, which is 186 newtons. And for those of you keeping score at home in pounds, that is 41.8 pounds. So if you've ever read or seen, they've made a movie of it recently, John Carter of Mars, the idea is that the hero of the story is transported to Mars and is capable of making these huge jumps and running really fast. The reason being, he's a guy who's used to his body weighing 160, 170 pounds, and then he goes to Mars and it weighs 50 pounds. So all of a sudden you have all these muscles built from carrying 160, 170 pound frame, and they just have to carry 50 pounds, which means you would seem to have quote-unquote super strength. If you were on Mars, your body would feel so much lighter than it usually does. So again, mass and weight, they're different. Mass is a measure of the inertia of an object, and weight is the force of gravity acting on an object. Know those definitions, and know the equation for finding weight.